Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for section 8.1 entitled Multiplication Property of Exponents. And what we're going to talk about today is three different properties for how you can multiply to simplify exponential expressions into one single power. So we have to just refresh our memory a little bit on what an exponent is and what it means. And we have a couple of parts here to this expression, this x to the sixth. Remember, this number here at the bottom is called the base. And this number here, the 6, up at the top, this is your exponent. Okay, so the base is going to be the term that's larger in size, like actual physical size, not amount. It's going to be the one that's at the bottom, sort of. It's touching the bottom of the line of the paper. And it tells you what you need to multiply by itself. The exponent then is the little superscript. So that's always going to be the number that's smaller in size, not necessarily smaller in amount, but it's going to be floating up in the air, up above the base. And it tells you how many times you multiply the base by itself. So, knowing those two things, then we know that this expression could be written out as x times itself 6 times. So that's what x to the sixth means. And that's the way we say it, x to the sixth, or x to the sixth power. And that's what you call the whole expression altogether. You call it a power. So that's the name for the whole mathematical expression with a base and an exponent. And sometimes we get kind of lazy. Sometimes we kind of refer to a power as an exponent and vice versa. But really the exponent is just that little superscript. The power is the whole expression with the base and the exponent. And we can do exponents on our calculators. We can evaluate powers on our calculators. Depending on the calculator you have, if you have a TI calculator or a Casio or a certain version of a TI, or if you have the calculator on your cell phone, if you have Android, or if you have an iPod, you're going to have all different kinds of ways to enter exponents. Most of the time you're going to have a y to the x button. You might also have an x to the y button, depending on the version of the calculator that you have. Or you're going to have this little upside down V, which is called the caret key. And so when you type that into your calculator, if you were going to do 5 squared equals 25, for example, you'd have to do 5 and then the caret and then the 2. And then you'd have to hit enter or equals, and you should get 25. Okay? Same thing for that y to the x button. You should have to do 5 and then y to the x and then 2. Now, if for some reason you don't get 25, try switching the order of the numbers. So try doing 2 and then the y to the x and then the 5. Okay? So play around with your calculator until you get whatever combination of numbers and buttons to get you 25. And then that's the order that you would want to type in all of your exponential expressions. Okay, so we're going to talk about a couple of our properties here. The first of the three is going to be the product of powers property. And we've already talked about what x to the sixth means. Okay, in our opening notes there, we said that x to the sixth meant that you take x times itself 6 times. So here I'd have x to the fourth, which would be x times itself 4 times. And then I have x squared, which is x times itself 2 times. And then this little dot in between says that I'm multiplying those two expressions together. So really now, let's see if I can move that a little closer. Now I have x times x times x times x times x times x. So I have 6 x's altogether that I'm multiplying. So the shortcut for these types of expressions then, where you have x to the fourth times x squared, the shortcut to evaluate them is simply to add your exponents. And that's what the product of powers rule tells you. It says that when you multiply powers that have the same base, you add the exponents. So that wouldn't work if you had x to the fourth times y squared. You could not combine those with the product of powers property. Okay, the bases have to be the same. Okay, then we also have this expression where you have x to the third squared, and inside the parentheses we have x to the third. So if we were going to simplify that, I would write it x times x times x times itself 3 times. But then that expression is being squared. So that means we have x times x times x times itself, x times x times x. So again, all together, I have x to the sixth. So the shortcut then for this property is that when you have a power to a power, you want to multiply those numbers. And that's what the power of a power property says. It says that to find the power of a power, you multiply the exponents. And then we also have a kind of like a distributive property a little bit. Okay, this expression here, we have an x times y inside our parentheses, and it's being raised to the sixth power. So that means I have x times y 6 times. There's 4 of them, 5 of them, whoops, and 6 of them. Okay, and they're all being multiplied together. So really, I have 6 x's, I can go through and count them, times 6 y's. So that's the simplified version of this expression. And what they've really done is they've kind of distributed that exponent to everything that's inside the parentheses. And that's the power of a product property. So we're going to take a look at these properties then. And here in example 1, you're going to see some problems like this in your homework where they just want you to kind of fill in the blank, so to speak. They're going to have these little question marks here. And they just want you to figure out what number that exponent would have to be in order to make the statement true. So it says copy and complete the statement. Okay? So here you have to know that you're multiplying your bases together, and the bases are the same. So that property is the product of powers property, which says that you would have to add your exponents together. So that means we have 2 plus whatever is supposed to be in that question mark spot has to equal 9. So then you know, oh, okay, well, 2 plus 7 is 9. So really we would have 4 to the 7th power there. Okay, now for part B, this one's a little trickier because there's something that's missing. Really, we have a kind of like a ninja or an invisible exponent. He's hiding. So anytime you have an exponent that's a 1 or a power of 1, it's not going to be written in. It's usually just left as the variable. So you have to know that that w is really w to the first power. But again, we're trying to figure out what goes in that little spot there for the question mark. So something plus 1 would have to equal 4. And again, I know I'm adding because I'm multiplying my bases. So the shortcut then is to add your exponents. And then here you could do 4 minus 1 to figure out that that little spot would have to be a 3. Okay, for part C now, we're doing a different property. We're doing the power of a power property. So here, remember, the shortcut is that you multiply. When you have a power to a power, you're going to multiply. So you have to think 3 times what is 9? And that would be 3. And then for part D, the little question mark and the number have flip-flopped from how they were written in part C. Doesn't matter though, we're still multiplying. So you'd have something times 4 equals 8, and that is going to be 2. Now it's a common mistake for students to write down that the answer is 4 because 4 plus 4 is 8. So make sure that you're remembering clearly as to when you use the addition property and when you use the multiplication property. When you're multiplying or when you have a power raised to another power, that's when you multiply. When you have a power, a whole expression, times another power, a whole other expression, that's when you add. So another way to think of that is if you have one base here, you're going to multiply. If you have 2 bases, then you add. Okay, for example 2 then, we're going to now be given all of our exponents and all of our bases. So we're just going to simplify these expressions. We're going to write them as a single power. So for part A, I have 5 to the second and 5 to the third. Now if you want to think of this as 5 times 5 and then 5 times 5 times 5, you can. So that can tell you that you're going to end up with 5 to the fifth. And then 5 to the fifth, we would want to evaluate that. It's going to be a pretty big number, okay? But you could evaluate that and then write the answer. Technically, it says, though, just to write the expression as a single power. So leaving it 5 to the fifth, that would be fine. That would be all that you'd have to do there. And again, the shortcut for that is just to add your exponents. Another common mistake is for students to multiply the bases and write 25 to the fifth power. But you don't want to do that. You don't want to multiply your bases together. Okay, keep the base the same. Even if it's a variable or if it's a number, you keep the base the same. So for part B, I have g to the third and g to the ninth. So I'm going to add the 9 and the 3, so that will be g to the 12th. Okay, now for part C, we're going to switch properties. Now I'm going to have my power of a power property. So I'm going to simplify this by multiplying. So 3 times 8 would be 24. So I'll have 7 to the 24th power. Now you could evaluate that, but it's going to be a huge number. Your calculator is probably going to put it into scientific notation because it is going to be such a big number. So we wouldn't really expect you to write out whatever 7 to the 24th power is. We don't want an answer for that because it's a little unrealistic to expect that big of a number for an answer. But 5 to the fifth in part A, you could evaluate that and get an answer if you needed to. And then for part D, again, we're going to multiply because I have a power to a power. So I'm going to multiply the 3 and the 7. So that will be 21. But my base, notice, is in parentheses here because my base is negative. So those parentheses need to stay around the -2 so that way I know that that negative goes with the 2 when it gets multiplied by itself 21 times. And this is another common mistake that students will do. Now, it doesn't happen when you have an odd power for your exponent, but if you have an even power, let's say you have -2 to the 20th, that's going to get you a different answer than if you do -2 to the 20th. And a lot of times students forget when they're typing this into their calculator to include the parentheses with the negative. Okay, those parentheses are saying that you want to take the negative with the 2 when you multiply it out 20 times. So this is -2 times -2, whoops, -2 times -2 times, etc., etc., etc. Okay, I don't know what's going on there. It kind of jumped. There we go. And this expression the only thing that's being raised to the 20th power here is the 2. So this negative stays out in front of the whole term, and then you do 2 times 2 times 2 times 2 times 2. Okay, so you're going to multiply all the 2's together, and then you will make the whole expression negative afterwards. Okay, our last example then is example 3, and this is where we're going to start to use all of the properties together, or use at least 2 of them together. We're going to see more of the distribution here as well. And sometimes when you do these problems, there's more than one correct way to think through this. So the way you do it might be different from the way somebody else does it, and that's okay. As long as you get the same answer, and it's the correct answer, whatever method you've used to get there, both methods might be completely correct. So you pick a method that works for you, and you use it consistently so that you can be successful. Now, with that said, for part A, there's 2 ways to look at this. Some students look at this and they remember order of operations. So they want to do what's inside the parentheses first. They want to do the -3 times the 2. So they write this as -6 to the 5th power. And then they evaluate that in their calculator and they get -7,776. The other completely correct way to evaluate this is to say, oh, this 5 has to be distributed to each thing that's inside the parentheses. So that's that power of a product property. So they do -3 to the 5th times 2 to the 5th. And -3 to the 5th is -243. And 2 to the 5th is 32. And then when you multiply those together, then you get -7,776. So that is the answer, whichever method you choose to use. And we'll leave that up to you. You can decide which way you think makes the most sense to you, but you want to use that every time then when you're working through a problem like that one. Okay, now for part B, I can't necessarily multiply the stuff in the parentheses together because I have an 8 and an 9. They don't tell me what the x and the y are. So I can't substitute a number in there and actually multiply this all out and get one number to the 4th power. So for this one, I do have to distribute that 4 to every single term. So I have to do 8 to the 4th times x to the 4th times y to the 4th. And then 8 to the 4th, I can evaluate that. So that'll be 4,096. And then I'll just write x to the 4th, y to the 4th. Okay, so part B really only has one way to help us simplify that. But part C and D, there's a couple different ways that we could do these problems. Part C is a little tricky because you have a number and you have an exponent or a power. Now, that 3 is being multiplied by the x to the 4th, and it's being squared. So you have 3 times x to the 4th times 3 times x to the 4th. So you have 2 of those expressions since it's being squared. And then 3 times 3 is going to be 9. And x to the 4th and x to the 4th. You're multiplying the bases, so you add the exponents. So you get 9 to the 8th, or x to the 8th. Now that's one way to think through that problem. The other way is to distribute. So you would distribute the 2. Let me rewrite the problem. You would distribute the 2 to the 3 and to the x to the 4th. So you'll have 3 squared and x to the 4th squared. And 3 squared is 9. And when you have a power to a power, you multiply. So 4 times 2 is 8. So you get the exact same answer no matter which way you choose to work through the problem. So we're going to do that again, that concept from part C. We're going to do that again here for this part of D. But we also have another term out front. Well, we're just going to leave that 4x to the third because he's going to get multiplied by whatever we get when we do the negative 5x squared. So you could think of it as negative 5x times negative 5x, and then you have a 4 times x to the third, negative 5x, I'm sorry, negative 5 times negative 5 is positive 25, and x times x is going to be x squared, and then 4 times 25 is 100, and x to the third and x squared, you have 5 x's altogether. That's one way to do that problem. The other way is, like we did before, to distribute that squared. So you would have 4x to the third times negative 5 squared times x squared. So you still have 4x to the third and 25x squared. And then you have your numbers here that you're going to multiply, and then your variables. So you get x to the fifth. So again, either way you want to think of doing that problem, it's completely correct. You need to try both of them, or if just by watching these notes you've recognized one that you know makes a lot more sense to you than the other, you want to use that as much as you can to help you simplify these problems. Okay, so today we've taken a look at 3 properties of exponents or powers. And basically what we've done with those exponents is we've added them, or we've multiplied them when we have a power to a power, or we've distributed. So those are the 3 basic functions that we're using today, or not functions necessarily as operations that we're using. Okay. Now this homework is meant to be easy. It's meant to be straightforward. I really encourage you to practice it though, because if you practice now when everything is quote unquote easy, then when we get more and more challenging exponent problems, you'll know those basic skills really, really well. And that way those more complicated problems will be really easy. So definitely practice this homework. And if you have any questions, come on by and see me before school.